Okay. Hello, class. I'm going to go ahead and start a recording for chapter 12, section 3, which is applications of scientific notation, applications for scientific notation. So I'm going to share my document camera with you. All right, here we go. Okay. All right. So 12.3 is application scientific notation. Okay, and I'm going to share with you this page 237. And let me just share this part with you first. So let me see if I can enlarge this. Page 237. So application scientific notation. So if n is a decimal number, then in scientific notation, capital N is equal to a times 10 to the n, where a is a number pretty much between 1 and 10. It can actually equal 1. See, it has that underscore. So we have less than or equal to, but it has to be less than 10. So it can approach it like 9.9, 9.95, 9.999. It just can't actually reach 10. It approaches 10. And n is an integer. And here are examples of integers. Okay. And commas are required for numbers that have at least 5 digits. So here's an example of a number, 34,824. If you count 1, 2, 3, 4, 5, it has 5 digits. So commas are required for numbers that have at least 5 digits. So these are a couple of things we're going to practice in this section. And notice commas don't go on the decimal side. So we put commas, if you think you're a place value chart, we put commas on the counting number side, but not on the decimal side. Okay. Okay. The other thing we're going to write is there's these steps here. There's 3 steps that we're going to write here. And this is to help you work with calculating products and quotients that have scientific notation. So here, what you would want to do in your steps, you want to write this down. You want to change the problems, the numbers to scientific notation, which resembles a times 10 to the n. And then you want to regroup all your a terms. Then you're going to use your calculator on that. And then you're going to regroup your powers of 10, your 10 to the n terms. And then you're going to use your exponent rules on that. Namely, from section 12.1, you're going to use the product rule and you're going to use the quotient rule for that. Okay. All right. So go ahead and, like, if you need to pause the video, go ahead and pause the video and write that down, and then start the video up again after you've written those 3 steps, because it'll take you a little while to write that down. And these problems, they usually take a little bit longer to compute, and so we usually don't put these on the test, but they are on your practice homework. They are on your homework, but on the test we don't include those on the test. We just include like the top part, scientific notation at the top. And the reason why we don't skip it in the curriculum, because you might have to take chemistry or you might have to take physics. And so that's why we include them in the curriculum, to help you in case you have to take, chemistry or physics. That will be important for you to know. Okay. Okay, so we start looking at the problems. Let's go to the ones that the math department made. And it's page 200. Okay, so notice they have 2 and 3700ths times 10 to the 6, and they want that in decimal form. Sometimes they'll call it decimal form. Sometimes I've seen some books call it standard form. So you want to be open to both. And what I want you to notice about this 10 to the 6, I want you to notice that 10 to the 6 is considered a large number. And why? How do I know that? Why do I consider it large? Just simply because the exponent is positive. That's really the reason why. It's not a negative exponent, because the exponent is positive as opposed to what? Not negative. Okay, so that's how I know that it's large. And so what that means is 10 to the 6, it will have a certain effect on 2.37 when you multiply it. It will also make your 2.37, which is considered your A, large too. Okay. So then you have to think, how do I move my decimal point so that happens, so that it becomes large, so that 2.37 becomes large? You want to move the decimal point to the right 6 times, because then that would make 2.37 large. So here's your decimal point, and you want to go to the right in that direction, not left, but right. And you want to move it 6 times. So the 37, that counts as 2 moves. But you need a total of 6. See, you need a total of 6 moves. So that means you're going to need 4 zeros, because 4 and 2 give you a total of 6 moves. Okay. So in your answer, you have, here's your 2, okay, and then you have your 3 and your 7. That counts as 2 moves. But then you have 4 zeros, 1, 2, 3, 4. And then really your decimal point is back here, right? It's in the back. The book doesn't really bother putting if it's in the back, it's understood. But you have your commas, 1, 2, 3, comma, 1, 2, 3, comma. That's hundreds, thousands, millions, right? That's over 2 million, right? That's 2,370,000. Okay. And then this would be your answer. That's called standard form. That's called decimal form. That's called decimal form, standard form. And if I check on my calculator, 2.37 times 10, and I'm going to raise it. See, raise it to the 6th power and hit enter. See how I get that answer that I got right here? You can check it. And it depends, the TI-30XS, it depends what kind of calculator you have, how many digits it can hold. This one, if I do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, no, 50. The TI-30XS holds the TI-30XX. It looks like it shows 15 digits in our screen, which is a lot, Most calculators, I think, show 9 or 8, I think. That's a lot. So I don't think you'll run out of space. I think I think the problems that the book will give you, I think you'll always be able to check your answers. Because I don't think they'll give you anything that has more than 15 digits in these exercises. So you should be always to check your answer. Now, number 2, write 5 and 9/10 times 10 to the negative 8. So I want you to make a note that 10 to the negative 8 is considered a small number. And like, how does your teacher know that? It's because the exponent is negative. Okay, not positive. So because it's negative, that's how I know that 10 to negative 8 is a small number. And what's its effect? what kind of effect does it have when you take a small number and you multiply it times 5.9? So what happens is 10 to the negative 8 makes 5.9 small also. Okay, so you have to think, well, how do I move my decimal so that I make 5.9 become something small? That means you want to move your decimal point to the left 8 times, because remember that was 10 to the negative 8. So you come over here to where your decimal point's at, which is right here, and you're going to tell yourself you're going to move to the left 8 times. So this 5 will count as one move. This counts as one of those moves, but then you're going to need 7 zeros because you're supposed to move a total of 8. So this counts as one move, and then 8 minus 1 is 7. So we need 7 zeros. So then you have the 5 written here, right? And you do have the 9, that's still part of your answer. That's not part of your moves, but it's part of your answer. And then you're going to move it 8 times. So this counts as one move, and then you need 7 zeros. 1, 2, 3, 4, 5, 6, 7. Okay, so 1, 2, 3, 4, 5, 6, 7, total 8. And then you can be formal. You know, this doesn't count as when you move. This is formal. That 0 is there. Now all of this is your answer. And we don't put commas on this side. We don't. And also all numbers have only one comma in them. So all numbers are allowed only one decimal point, I should say. I think I said comma a while ago. I meant one decimal point. All numbers are allowed just one decimal point. So sometimes the mistake I see is that the students have the original, like 5.9, they have the original still here, and then they move their decimal and they have the new one. You cannot, you have to remove the original one. The original one is no longer there, and you just have your new one. But so all numbers are allowed only one decimal point. So keep that in mind. Okay. And if I go to page 241, I think there you're 241, right? Okay. Oh, I'm going to wait on those. I was going to do 7 and 8, but these are writing them in scientific notation. So that's coming up. We'll do that after we do 3 and 4. Because see, 3 and 4 is writing it in scientific notation. So we'll do those first. So here, this is hundreds, thousands, million, right? This is 1,770,000, right? And they want you to write that in scientific notation. Okay, so scientific notation has this format: A times 10 to the n, where A is within this restriction of pretty much between 1 and 10, and it can actually include the 1. But that's how big A can be. If you think about money, it has to be between $1, it can equal $1, between $1 and $10. Okay, all right. So if you think of it that way. And so on your A, you have to move your decimal point, move your decimal point. And if you're like, well, I don't see it. If you don't see it, it's hidden and it's in the back, and it's imaginary in the back. But you're going to move your decimal point basically, in between digits, basically in between digits. Okay, so so when you play, we're going to play a little bit. You see your decimal points here, you're like, well, where am I going to move that? So people might say, well, what if I move it way in the front? What if I move it way in the front, in front of that 1? 7, 7. And somebody will say, well, what if I move it after the 1, 7, 7? And somebody might say, well, what if I move it after the 17, 17.7? And somebody might say, well, what if I move it after the last 7, 177? So we're just playing here, right? But you're thinking, where do I move it? There's only going to be just one correct place, like Goldilocks and the Three Bears. This porridge is too hot. This porridge is too cold. This porridge is just right. There's only going to be one just right location, one possible answer that you're going to choose. The other ones are going to be either too big, too large, or too small. Because remember, you want this between 1 and 10 idea. So like this one is too small. If you think about money, this is like about 18 pennies, 18 cents. This is too small. If you think about this one, $1.77, that one looks good. That one looks good. That one is a suitable $1.77. It's between 1 and 10. But this one's too big. 17.7. That's like $17.70. That's just too large. And $177, that is also too large. Okay. All right. So we're going to go with the 1.77. We're going to go with the 1.77. All right. So if we go with the 1.77, we have, we need this format, and that's our A. So you have 1.77 times 10, and we need to figure out what this is. Okay. So what you want to do is you want to, for the N, you definitely want to count your decimal moves. Okay, so how did we move? We moved from here all the way. We said we were going to go right there in between the 1 and 7. Well, how many moves is that? 1, 2, 3, 4, 5, 6. It's 6 moves. Okay, so now your choices are, do you go with 10 to the 6, or do you go with 10 to the -6? That's your question. So remember what we said. If you go with a +6, this is a big number. And this big number, when you multiply with 1.77, it will also make it big. And is that what you want? And if you look at that, yeah, that's in the millions. So you want to go with 10 to the 6. Okay. If you go with the -6, that's a small number. And that's a small number, where this is a large number. So this small number makes your A small, whereas 10 to the 6 is large. That makes your A large. Okay. So, and you can check on the calculator. If you're not sure, you can check both of them. If I do 1.77 times 10 to the 6, 1.77 times 10 raised to the 6th power. See how that gives you this back, the large number? Whereas the other one, 1.77 times 10 raised to the -6th power. So I'm using this key to activate the exponent, and I'm using this key here to activate the negative on that 6. And that gives me, see how that gives you a decimal small, see? So it's a small number and it makes it small, talking decimal small, and you don't want that, see? You don't want that. So yeah, you want to use this. And on your key, most of you who have the TI-30XS, you're going to have this key. If you have another another scientific calculator, you might have these keys. Nobody has all three of these keys. If you have a scientific calculator, you just have one of those keys, and the older ones will have one of these. And so you have to look for that. It might be in the same spot. I can't guarantee where it will be. That's why I try to get everybody to get the same calculator that I have. But you might have one of those keys and that will activate that. Okay. And on number 4, okay, so let me box this. So this is our answer here. This is our answer. And on number 4, you want to write, this is, if I read this out loud, this is tens, hundreds, thousands, 10,000s, 100,000s. If I were to read this out loud, I would say 465 100,000s, tens, hundreds, thousands, 10,000s, 100,000s, 465 100,000s with a THS, but you want to put that in scientific notation. So again, you need this format, A times 10 to the n. So if you try to play with where you can move it, some people might say, well, what if I move it in the decimal? What if I move the decimal in front of the 4? And somebody might say, well, what if I move it after the 4? And somebody might say, well, what if I move it after the 6? And somebody might say, well, what if I move it after the 5? Okay, and only one of them is acceptable. This first one is too small. This is like about 47 cents. That's just too small. This one looks good, $4.65. That's, remember, this has to be a number between 1 and 10. So that looks like a suitable A. But these are just too big. The 46.5 and the 465, these are just too big, too large. So forget about those, okay? Forget about those. So you want to go with this. So your A times 10 to the n, your A is 4.65 times 10. Now you need an n. So for your n, you do need to count your decimal moves. And so to go from here all the way you took it here to in between the 4 and the 6, how many moves was that? 1, 2, 3. That was just 3 moves. So your choices are, do you go with 10 to the cube, or do you go with 10 to the negative cubed? Okay, well, look what you need. You need smallness. So you want to go with this one. This is a small number, and that will generate another small number. So you want to go with this one. Over here, we went with 10 to the 6, but here you want to go with 10 to the negative cube. So I'm going to put a negative cube there. That's a small number, and when you multiply it 4.65 times that, it will also make it smaller, so small. I can check on the calculator, 4.65 times 10 raised to the negative 3rd power. See, that works. The other one, 4.65 times 10 raised to the 3rd, that's too big. You don't want that. Okay. Okay, now let's do 7 and 8, because 7 and 8 are of these. 7 and 8 are of this type down here, but they're trying to teach you about this, that it can actually equal 1. That's what they're trying to teach you on those. So if you look at 7 and 8 on page 241, they want you to write 100 in scientific notation. So your decimal point is back here, and scientific notation means A times 10 to the n format. So you want to move your decimal point right here after the 1. So your A is 1. 1 times 10. And your choices are, you moved it 2. So you're like, do I go with 2 squared or do I go with 2 to the negative square? Well, you want something big. This is considered big. Small is anything that's decimal small. So this is considered large. So you want to go with this one. 10 squared is large. So you're going to go with 10 squared. Okay, and then you can check. 1 times 10 raised to the second power, see, versus 1 times 10 raised to the negative 2 power, see? So you want the top one. And then on number 8, again, you want this in scientific notation, a times 10 to the n. So you need to move this way over here in front there. So you have 1 times, because anywhere else it's too small. If you put it in front of the 1, that's like 10 cents. That's like 10 cents. That's like 10 cents. And that's just too small. It needs, remember, it needs to be, A has to be between 1 and 10, right? So these two are teaching you how it can be 1. And then times 10 to what power? Well, how many times did you have to move it? 1, 2, 3, 4, 5, 6, 7, 8, 9. So you're like, do I go with 10 to the 9 or do I go with 10 to the negative 9? Okay, well, this is considered decimal small. This is considered small, decimal small. So you want to go with this because this is considered small. How do I know it's small? Because it has a negative exponent. So you want to go with that. You want to go with negative 9. Okay, negative 9. And if I check that on the calculator, one times 10 raised to the negative 9. See, that gives me what I need. The other one's going to be too big. 1 times 10 raised to the 9 power. See, that's too big. Right? Okay, so this is your answer. Okay. And then these 5 and 6, we wouldn't put 5 and 6 on the test because they do take a little bit longer than these other problems that we showed you. The other problems that we'll put the other problems that we showed you on the test, but these though will be on your practice. You'll probably have some on your practice homework. And because and some of you might be taking chemistry. So this is where you use those little steps that we wrote down. So the first step says, this is for these steps here. You want to change all your little numbers to scientific notation, a times 10 to the n. So like all of these need to be put in scientific notation. On number 6, these are already done. This is already scientific notation. This is a number between 1 and 10. And this is scientific notation times. So these 3 are good, but this one isn't. This one you'll have to fix it. So if we do that first, put these in scientific notation. For this one, we would have to move the decimal after the 7.2, because now that's a number between 1 and 10. You need a times 10 to the n, and a has to be a number between 1 and 10. So you moved it 2 times and you want small. So you need -2, okay? And then that's going to be that parenthesis times, then this is going to get moved after that 3.3 times 10, and that moved 1, 2, 3, and that has to be a -3 because you want smallness. And then you can always check on your calculator if you're not sure if it's too or a -2, you can always just double check. If you do 7.2 times 10 raised to the -2, you see how you get that back. Okay, so that works. You can always check that. And on the bottom, you want to move this decimal in between the 5 and the 4. And you just move that one time, and you want this to be small, 0.54 is small, times, and here you want to move it between the 1.1. And again, it's going to be decimal small, and you're moving that just 2 times. Okay. So if you want, you can check those on the calculator. But if I check this last one, 1.1 times 10 raised to -2, you see how I get that back. Okay. So these are all negative exponents because you want something small. So these are all small. And this one, though, is not considered small. Small is considered decimal small. So this is not considered small. This is considered large. This one, when you move it, your decimal is here. You can move your decimal right here. It's going to become 7.76. And you move it twice, but that's going to become +2 because you want something that's considered large. And if I check down the calculator, 7.76 times 10 squared. And you can even do the square. See the square key? You want to do squared? See? Or you can do the hat. 7.76 times 10, that with the hat. Either way, you get 776 using the exponent squared. When you have a squared, you can use that squared. It's only for squares, or you can use the hat key. Okay. All right, so that was the first step, is to change them into scientific notation. The second step is to regroup all your powers of A's and then use a calculator on it. So if I do that here, A's, these are considered A. That's an A, that's an A, that's an A, that's an A. Even over here, this is an A, this is an A, this is an A, that's an A. So you regroup all your A's. So this would be 7.2, and then see, times 3.3 in parentheses, and then all over parentheses 5.4 times 1.1. So you're regrouping all your A's. And then, so let me write that down here. You're regrouping your A's, and then you're going to use the calculator on that. And when you use your calculator on that, you do need to put the parentheses. If you don't put the parentheses, it'll have an order of operations error. And the parentheses are right here. See? So you do parentheses 7.2 times 3.3, close parentheses, then division, open parentheses, 5.4 times 1.1, close parentheses. See, that gives you 4. Okay. If you don't put the parentheses, let me do it without the parentheses, and you'll see how you'll get it wrong. If I don't put the parentheses, 7.2 times 3.3 divided by 5.4 times 1.1. See, if I don't put any parentheses, see how I get 4.84? See that? So you do need the parentheses. Okay, and then you're going to regroup the powers of 10, and then you're going to use your exponent rules, the product rule and then the quotient rule. So I do that over here. Those, if I highlight those in purple, we're talking about these here. Okay, so you have 10 to the negative second times 10 to the negative third, all over 10 to the negative 1 times 10 to the negative second. Okay, and I don't have to put parentheses on those because I'm not going to use the calculator on that. So I'm regrouping our 10 to the n, and I'm gonna use what did I say? The product rule. And then I'm going to use the quotient rule. So I'm going to use the product rule first. Product rule tells you to add. When multiplying like bases, you add the exponents. So this is -2 plus -3. On the bottom, 10, -1 plus -2. So I'm adding the exponents. -2 plus -3 is a -5. So now this becomes 4 times 10 to the -5. And the bottom, -1 plus -2 is 10 to the -3. So you have 10 to the -5 over 10 to the -3. And now I'm going to use the quotient rule, right? It's called the quotient rule. So first I use the product rule, then I use the quotient rule. And the quotient rule tells you, right, to subtract, right? Subtract top minus bottom, top exponent minus bottom when dividing like bases. So I have 4 times 10, and I have -5, take away -3, because it's top minus bottom. And in math, two negatives like that side by side end up making a positive. So that's really -5 plus 3. So that's 4 times 10 to the -2. And then that would be it. That would be your answer for that. Okay, you're done. This is scientific notation, and it meets that. It's a times 10 to the n. Is that a suitable a? Yeah, it's a suitable a. If it were not a suitable a, then you'd have to do some work on it to make it a suitable a, right? You have to do your moving. So if it were not suitable, you'd have to do some movements, do some movements on it to make that a suitable a number between 1 and 10. Okay. But yeah, that's suitable. 4 times 10 to the -2. Okay, and then number 6, we already did the first step. We already changed everything to scientific notation. Now we're going to regroup our A's. So I'm going to have 3.7 times 7.76 all over 8.7 times 1.1. And we're going to use our calculator on that. So if I have open parentheses, 3.7 times 7.76 close parentheses divided by open parentheses 8.7 times 1.1 close parentheses. Okay, so you see that? And look how long it is. And that's why they tell you to round your answer. See, round your answer to the nearest thousands. They tell you that because they see how long it's going to be. It was 3.000 20 89 86. Okay. So you can freeze your screen if you want. Okay, if I round that to the thousands, tens, hundreds, thousands. Tens, hundreds, thousands, and then look at the number to the right. Is that 5 or more? Nah. So it stays 3.000. Okay. And don't leave it as 3. They said round it to the thousands, so you do need 3.000. Even though there's zeros, you need that. Okay, because they said thousands. Okay. Times. Okay, now we're going to do, so first what we did was we regroup our A. Now we're going to regroup our 10 to the n. So we have in purple, we have 10 to the negative third times 10 squared over 10 to the sixth times 10 to the fifth. Okay. And I'm going to use the product rule, which means I'm going to add -3 plus 2, and on the 10, 6 plus 5. So I'm adding, when you use a product rule when multiplying like bases, you keep the base and you add the exponents. So -3 plus 2 is a -1. And on the bottom, on 10, 6 plus 5 is 11. Okay, so now I'm going to use the quotient, right? The quotient rule. So I'm going to subtract top minus bottom, top minus bottom. So I have approximately 3.000 times, so 3.000, that's your suitable A, times 10, and you're going to do -1 minus 11, top minus bottom, which is -1 plus -11, right? When you're subtracting sign numbers, these are sign numbers, see the negative, you want to rewrite it as an addition problem, adding the opposite. And -1 plus -11 is a -12. So then we have this being approximately 3.000 times 10 to the -12, because -11 and -1 is a -12. And I'm going to box that, and that would be considered my scientific notation format for that. Okay. Okay. And I think the last thing I'm going to do is go over, I always try to go over the true and false on page 238. Okay, so you can freeze the screen if you're still writing or thinking about that. You can freeze the screen and then turn it back on when you're ready. But I'm going to go right now to the true or false just to see what they have here. So this is on page 238. So it says that the exponent in the number 1.4 times 10 to the 4, so talking about the number 4, this exponent, we're talking about this, right? The exponent indicates that the decimal point should be moved 4 places to the right. Okay, so yeah, this is 4 is considered a large number. How do I know that? Because it's not negative, it's a positive exponent. So the large number will make this 1.4 large. So how do you make this large? By moving the decimal to the right 4 times. So that's true. And this would become 1, and you move it to the right 4 times. So that's 1 move, 2 moves, 3 moves, 4 moves. So you would have 3 zeros, and that 4 counts as a move. And it's 1, 2, 3, comma. Technically the decimal's back here. Number 2, the exponent in the number 2.5 times 10 to the negative third, so talk about this exponent. This indicates that the decimal point should be moved 3 places. Okay, yes, 3 places what? To the right. Yeah, and I would say that's false. This is a small number. How do I know that's small? Because it's got a negative exponent. The effect that has on 2.5 is it will make 2.5 small also. The only way to make that small is to move it to the left. So this is just being formal. That doesn't count as one of your moves, but this does count as one move, and you need 3 moves. So that means you just need these 2 zeros and then 2. There's your 3 moves, 1, 2, 3. And then of course you can't forget about the 5. Okay. Also, if you use your calculator, you can use your calculator on these. Type this in and you should get that. Type this in, you should get that. Okay. And I can show you on that. I can show you on this 2.5 one. 2.5 times 10 raised to the negative third. And you see how we get that. So you see, checks off. Okay. Number 3, the number 3 and 53 hundredths times 10 to the 5th, that's less than this 8 and 72 hundredths times 10 to negative 4. Okay, I'm not sure. I'll have to figure what that is. So this is large. This is going to be large also. So I'm going to move this to the right 5 times. So this is a 3, 5, 3 that counts as 2 moves. 3 moves, 4 moves, 5 moves. So this looks like 353,000. This one, this is a small number. So I'm going to have to move this to the left 4 times. So this is 0 point. And then I have 1, 2, 3. And then there's your 4th move. And then I have 7, 2. Okay. So then you can check it on the calculator. If I check these on the calculator, 3.53 times 10 raised to the 5th. Looks good. Okay, the other one, 8.72 times 10 raised to the negative 4th. Yep, looks good. See that? So you can freeze that if you want, but that looks good. And then now they were saying, let's see, this number is less than this. This is false. It's false. It says it's false. This number is greater than. That. Okay, and the last one, the number 4,000 written in scientific notation is this. Yeah, so scientific notation, it's, well, let's see. I said yes, but let's wait. 4,000. Scientific notation needs a times 10 to the n. And your a has to be a number between 1 and 10. So 4,000, you need to move it so that it's like behind the 4. Oh, and this is not good. See, this is considered, that's too small. That's not a suitable A. That's not a suitable A. It's got to be like between $1 and $10. So the 4, this needs to be a 4. Okay, times 10. And then how many times did you move it? 1, 2, 3. So you're like, do I go with 10 cube or do I go with 10 negative cube? Well, what do you need? This means large. So you want to go with this one because this is large. This negative is small. You need large. So you want to go with 10 cube. So 4 times 10 cube. 4,000. That works. Okay. If you check this one, 0.4 times 10 raised to the 4th. Interesting. 0.4 times 10 raised to the 4th. Interesting. Good thing I checked that. That one does give you 4,000 also, but it doesn't meet the requirement. It looks like scientific notation and it does equal 4,000, but what's wrong is this A. This is not a suitable A. A has to be a number between 1 and 10. So that's a good tricky problem. It's a tricky problem. It's a good one. It's a good distractor, but that's false. Okay. And then I'll just leave these here. These, you don't have an answer key. These are the answers. So I'll just leave this here. If you want to freeze that, and then you can check your work. And this is again on page 238. So you can freeze that screen. You can do the problems and see if you get that. And then I'll also push this up so that you can freeze that if you want to do those problems and then check your work. Because those, I have an answer key, those should be correct. Okay, those are just extra problems if you want to do those and check them yourself. Okay, these are the ones, these here, these calculations, you would do those the way that using these steps here, using these steps, the way we did number 5 and 6, where we did 5. So these two are like numbers 5 and number 6 on page 241. That's how you do those. Okay. So I hope that helps then. Okay. Good luck with your studying.